The universe is about 14 billion years old.
Ever wondered how we actually figured it out?
That's where this guy comes in. In 1929, Edwin Hubble confirmed that the universe was expanding.
That nearly all outer space objects were moving away from us, and that generally the further an object was, the faster it was receding from us.
Before going further, we first need to understand what Doppler shift is.
Say we have an object emitting sound waves. Notice how the waves are spread out behind it and bunched up in the front. An observer behind it would hear waves of longer wavelength or lower pitch.
Like an ambulance moving away.
Similarly, for an object that is receding and emitting light, its observed wavelengths are longer and more towards the red end of the spectrum, or redshifted. By analyzing light coming from distant galaxies, we can see that their observed wavelengths are redshifted, so they are moving away from Earth. For more distant galaxies, light is more redshifted.
Therefore, the Hubble's law states that
the recession speed of a galaxy is proportional to the distance from us, or rewritten as this, where h0 denotes the Hubble's constant.
Now let's look at a balloon model.
If we imagine the galaxies as dots on the surface of an expanding balloon, we see that a dot moves away from every other dot at a constant rate, so a galaxy also recedes from every other galaxy at a constant rate. Now if the universe is expanding, it must have all been very close together at some time. That means that the universe once had a beginning, the Big Bang.
How long ago was it? Let's estimate this using the Hubble's constant.
We know that speed equals distance over time, and therefore time equals distance over speed. We substitute v equals Hubble's constant times d, so the equation becomes this.
Hence, the age of the universe is the inverse of Hubble's constant, that is approximately 14 billion years. Everything around us, including us, was created during the Big Bang. We could therefore suggest that we all have the same age.